Good morning, Science 10s. Today I wanted to talk to you guys a little about atomic theory. So we're going to talk about atoms and parts of the atom, the energy levels, how to draw energy level diagrams, and how to draw Bohr diagrams. So you can follow with me on your atomic note guide number 1 here, and starting with what is an atom? Well, it's an element, right? And it's the smallest part of an element that still has properties of that element. So our elements are on the periodic table, and you can look up, for instance, a metal like silver and a non-metal like chlorine, and they're two different elements, so they're going to have very different properties, and their atoms will be different. You already know the 3 types of subatomic particles. So you already know protons are positive, they're in the nucleus. Neutrons are neutral, they're in the nucleus as well. And electrons are negative, and they're outside of the nucleus. And so the protons and the neutrons that are together in the nucleus of the atom, that's where most of the mass is. And then there's a whole bunch of empty space, and then these energy levels, and the energy levels are where the electrons exist. So there's this huge amount of space outside a nucleus, and they can be empty or they can contain electrons. So with our little diagram here, we see here's the nucleus, and we see the positives and the neutral particles, the neutrons. And then you notice that these little dots, and these are the electrons, which are sometimes shown as dots. They're sometimes shown as E negatives. And you can see that this is an element, an atom of calcium. And you can see that it has several of these, look like little layers, these little circly things, and those are the energy levels. And so this first energy level, that's its lowest energy level, and you'll notice there's 2 electrons inside there. Those energy levels that are closest to the nucleus have the lowest amount of energy because, again, it's positive inside the nucleus, and they're very attracted to them, and so they're held very tightly. And here, this calcium atom, you can see that here's its second energy level, and there's electrons all the way around there. And then it has a third energy level, and way outside here is the 4th energy level. And these 2 little electrons way out here, those are the highest, the most furthest energy level, and they're very loosely held. Why? Because they're a long ways away from that positively charged nucleus. Okay, so moving on then to our next page, we can then talk about what is the atomic number. So you can read this little chart and do the chart, and then the atomic number, well, that's just simply the number of protons in an atom. And you can use that to know the different elements apart, right? Each element on the periodic table has its own unique atomic number. So the periodic table has all of the elements arranged by their atomic number. So the number 3 here in the top left corner, like lithium, that tells you the atomic number, the number of protons. Okay, so protons in the top left corner. It also shows you on each little square, each little element of the periodic table, the element symbol. So always a capital letter first and then a small letter. So Li for lithium. Here's his name. And you don't need to worry about some of this other stuff like this you'll learn about next year in Chem 20. Atomic molar mass, we'll learn about that a little bit later in Science 10. And then the ion charge, the most stable or the most common ion is listed first. So when you look up on your periodic table, and so I'm just going to pull up one here, some of these metal elements kind of in the middle, these transition metals, you'll notice that they have 2 different charges. So like 5 plus, 4 plus, 3 plus, 2 plus. Well, the first one listed is the most common ion charge. Okay, so the most common is the very first one listed. Okay, so generally the ion charge for all of these metals on this side are going to be positive, right? So metals are positive, they are cations, and you compare that to on the right side of the periodic table, it doesn't show, but these guys are negative. So nitrogen, oxygen, fluorine, all these non-metals, they are anions, they're negatively charged ions. Okay, so if you know the atomic number, you know the number of protons, the positives, and because all atoms are electrically neutral, the number of protons has to equal the number of electrons. The positives have to equal the negatives. So that is how we are going to figure out how to draw these energy level diagrams or Bohr diagrams. There's two different types of diagrams you're going to learn how to do. So we have to understand that if you know the atomic number, you know the protons, you also know the electrons. They're equal to one another because atoms are no charge. They are neutral. The maximum number of electrons in every energy level is going to equal the number of electrons in each period. So 2 electrons in the first period, 8 in the second, 8 in the second, and I meant elements, and that's how many electrons you're going to have in your energy levels. So if we just go to our periodic table for a second, remember that periods go side to side. Okay, so I'm showing period 1. Helium, and on the other side, way over here, is hydrogen. So there's 2 elements, therefore 2 electrons are maximum in that energy level. And if you look all the way across this energy level, going way back over to the left side with lithium and beryllium, count up and you see that there's 8 elements, so therefore 8 electrons. This period, our third period, has 8 elements, and so therefore that energy level would have maximum of 8 electrons in it. Okay, so let's now look at the number of electrons in the outermost energy level is also going to equal to the group number. And so for instance, if it's a group 2 element, there's going to be 2 valence or 2 outer energy level electrons. So how do I make an energy level diagram? Well, you're going to draw out the nucleus, and you have to show the number of protons that are inside the nucleus. Your first energy level will have a maximum of 2 electrons. You fill it. If there's more than 2, you move on to a next energy level. You draw that second energy level line. You have a maximum of 8 going in there. Then the third energy level, maximum of 8. Fourth energy level, maximum of 18. So the best way to do this is let's take a look at an example. So chlorine has an atomic number. Well, let's look up on our periodic table. Here's our periodic table. Here is chlorine. So this number in the top left here is the atomic number. That's the number of protons. He is in not the first period, not the second period, but the third period. And so that is going to give us some information. And so is this, the group number. The last digit here in the group number tells us the number of electrons. That'll be 7 electrons in the outermost, the valence energy level. Okay, so 17, group 3, and 7 electrons. So let's fill that information into our notes now. Chlorine's atomic number is 17. That is the number of protons, also the number of electrons, because atoms are neutral. What period did we say it was in? 3. Well, that tells us how many energy levels it's going to have. So how do I draw out a Bohr diagram? Well, I start out with the number of protons in the nucleus, and that you get from your periodic table and atomic number, so 17 protons. Then we know that there's going to have 3 energy levels. Okay, the first energy level, here's our guidelines, can only have 2 electrons. So we're putting our 2 electrons in, but we've got 17 in total that we have to have. So they're not full yet. So we have to have a second energy level. Okay, and so I'm going to put the maximum number of 8 electrons in there. Okay, so, but guys, now that's 10 electrons. We have to have a total of 17 electrons. That's not enough. So guess what? We need a third energy level. And in that third energy level, that's where the last 7 electrons are going. So 10 and 7, that's a total of 17 electrons. So if you look at our energy level, here's our first energy level, and he has 1, 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8 in the second energy level. And in this outermost energy level, the valence, 1, 2, 3, 4, 5, 6, 7. So he can have a maximum of 8, but he does not have one here, right? He is missing that 1 electron. He's group 17, so he has 7 electrons in that outer energy level. But boy, those Bohr diagrams take up a lot of paper. So we can do a simpler way of showing this, and that's called an energy level representation. So same deal, we take our number of protons and we draw a little nucleus, and then we draw a line. And instead of having to draw these little circles, these little orbitals, we just draw a line. 2 electrons in the first energy level, 8, that's a maximum number. Well, that's 10 electrons there. But you know what? We need a total of 17. So where does our last 7 go? Well, they're going to go in that third energy level, in that outer energy level. Okay, and so I'll do one more example for you guys, and then you should be able to figure out how to complete this booklet and the handout on the Alchem energy levels as well. So we're going to take a look at our periodic table, and we're going to find sodium. So we find sodium has an atomic number of 11. So that means that we're going to be working with the number of 11 protons, and that is equal to 11 electrons. Na is sodium, and he has a 1 positive charge. So you can use your data booklet to fill up the rest of that little periodic table square, that little element. Okay, so what period is sodium in? Well, let's take a look. Period that sodium is in. Okay, remember, sodium is a metal, so we're looking to the left-hand side of our periodic table. 1, period 2, period, here he is here. Sodium, period 3. So period 3 tells me the number of energy levels that he is going to have. So we know his period is 3. It means he has 3 energy levels. Okay, so we're going to set up our Bohr diagram and then our energy level diagram. In fact, you know what? I'm going to let you do it. I'm going to let you try your Bohr diagram and the energy level diagram, and then I am going to show you what mine turned out as and see if you did it correctly. All right, so you're going to figure out the Bohr diagram and the energy level diagram. And then you also have this Alchem energy level diagrams to complete. And so this is pretty straightforward. You're just looking and you're going to do exactly like this. Our little energy levels, group 1, group 2, and then here's group 18, our noble gases, group 17, our halogens, group 16, group 15, 14, and 13. So you can fill these guys out. That's meant to say 17. Okay, so you can fill out the energy level representations of these guys and then check your work on that. Okay, so for now, I'm going to sign off. I'm going to do one more quick video showing you, again, Bohr versus energy level diagrams. In the meantime, if you need any help, michelle.ledeen@ghsd75.ca. All right, talk to you later.